Heat. Heat. What is heat? Heat is a form of energy that flows from one object to another. It is the flow of kinetic energy. So, in what direction does this heat flow? It always flows from a hot object to a cold object. Heat transfer. Heat transfer. Conduction. Let us take two blocks. One is hot and the other is cold. Now, the two blocks are brought into contact with each other. Heat transfer starts taking place from the hot body to the cold body. Finally, heat in both bodies reach an equilibrium temperature, which is the average of the two initial temperatures. Then heat transfer stops. This type of heat transfer is called conduction. Convection. Convection. When heat transfer takes place from one place to another in fluids and gases, is called convection. There are two types of convective heat transfer. 1. Free or natural convection. In this, the fluid motion is caused by the density variation or temperature variations. 2. Forced convection. There are two types of forced convection. A. Induced type. In this, the fluid is sucked over the heat source. B. Forced type. In this, the fluid is forced over the heat source. Radiation. Notice the flame below. Heat travels upwards by convection. But it also travels sideways by electromagnetic waves. Electromagnetic radiation can be described as a stream of massless particles, called photons, each traveling in a wave-like pattern at the speed of light. States of matter. What is states of matter? All matter on this planet is in three states. 1. Solid. 2. Liquid. 3. Gas. The states of all matter can be changed by adding or subtracting heat. Examples. Subtract heat from liquid water. It changes to solid ice. Water minus heat equals ice. Add heat to solid ice. It changes to liquid water. Ice plus heat equals water. Types of heat. There are two types of heat. Sensible heat. This is heat which you can sense, meaning you can feel this heat. When this heat is added or removed, there is change in temperature but no change in the state. This can be measured by an ordinary thermometer. Latent heat. Latent heat. This is the heat required to bring about a change in state of a body. This heat you cannot feel, nor can you measure it by an ordinary thermometer. When this heat is added or removed, there is no change in temperature. See the change of state in the coffee. Water state, coffee. Change to vapor state, steam. Latent heat that was added escaping into the air. Units of heat. The most commonly used units for air conditioning are 1. BTU. This stands for British Thermal Unit. It is the heat required to raise the temperature of 1 pound of water by 1 degree Fahrenheit. 2. Kilocalories. It is the heat required to raise the temperature of 1000 gram of water by 1 degree centigrade. 3. Ton. It is the heat required to melt 1 short ton, that is 2000 pounds of ice in 24 hours. 1 ton equals 12,000 BTU per hour or 3024 kilocalories per hour. Enthalpy. What is enthalpy? Air contains sensible heat and latent heat, in the form of water vapor. Enthalpy is the total heat content in the air. The unit is BTU per pound of dry air in IP units. Enthalpy can be determined from a psychometric chart, by plotting the supply air, and return air conditions. In an AHU, the difference in enthalpy of return air, and enthalpy of supply air, will give the amount of heat being removed, at that given point of time. Refer to given example. Enthalpy of the return air equals 26.6 BTU. Enthalpy of supply air equals 20.5 BTU. Therefore, the heat being removed from the cooling coil equals 20.1 BTU per pound of air leaving the AHU. Psychometric chart. Plot the wet bulb temperatures and enthalpy. Assume supply air wet bulb 50 degree Fahrenheit. Return air wet bulb 60 degree Fahrenheit. From the chart, return air enthalpy equals 26.6 BTU. Supply air enthalpy equals 20.5 BTU. Humidity. It is the moisture content in the air. The unit is grains. Air motion is about the movement of air, in the air-conditioned area. If the air circulation is not proper, then there will be hot spots and cold spots in the room. This is not desirable. Air purity. Air-conditioned buildings are like closed boxes. Therefore, an air conditioning system must ensure a good healthy environment inside, for the occupants. This is done in two ways. 1. Filters are used to control dust and pollutants. 2. Fresh outside air is added, and stale inside air is exhausted, to maintain good indoor air quality. Air is filtered before it is delivered into the air-conditioned area. Basically there are two types of filters, pre-filters and refilters. Pre-filters are placed in the return air stream, and refilters are placed in the supply air stream.